Good afternoon and welcome to Flat Earth United. Joining me on this beautiful day is Snack to the Future, Nick of Forget Word, and Jimbo. How are you all doing, gentlemen?
Good, Nathan. Thanks. Thanks for having us.
Chipper. Perfectly chipper.
Smashing.
I think Snack might be a little bit quiet. Can you say hello, Snack? I might have to turn you up a little bit.
Hello.
Maybe not. No, that's beautiful. So we've been chatting away for probably the best part of an hour about various different things. And the conversation, to get it started up again, came from Nick asking about data, and I'm going to use that in a very loose way, traveling through various mediums of atmosphere. And that conversation got extremely in-depth because we've got Jimbo here, who has an extensive knowledge about these sorts of subjects. And I'll lead the conversation a little bit more and then let Jimbo carry on. From what I gathered, being the layman in this, definitely the layman in this conversation, Jimbo was explaining that all information that travels along the lines of communication, be they through the cell towers from your phone, they are carried as packets of data, regardless of potentially whether or not it's even a phone call on your landline. But all of it is essentially the same amount, the same type of information, and that can be transferred down the lines, cross oceans, the satellite thing. Maybe I'll stop leading from there, Jimbo. Maybe you can carry on from that point.
Well, it's hard to say, because no one can really prove whether satellites exist or not, although there are a lot of people who highly doubt their existence. But in today's world, you have a cell phone. You're not actually talking directly to another person. It's going through electronic switching and circuits. And today, things are sent over wire in the form of datagrams or data packets. And it's sent over what's called an internet protocol or internet packs. Your voice is broken down into the same type of packets that websites are sent around and other information sent around the web with. It's sent over the internet with all the other data. It's recombined at the other end and goes to where it's got to go, to the receiving cell phone. So your cell phone call is actually going through the internet and through internet protocol, just like everything else. The one thing is they have satellites now that are basically balloon satellites. The Operation Loon is Google, and they've found a way to launch at will internet data balloons with transmitters and transceivers on them that help to redistribute data information all around the world. They send up thousands of these things. There's not much question, 99% of all world telecommunications and data traffic goes through the oceans, through cables, through towers, and through other means. Apparently less than 1% goes through over 17,000 satellites that are in these Goldilocks zone and geosynchronous orbits somewhere above us, 2,300 miles up or so.
I mean, one of the things you were detailing before we started was about the amount of power that's used, and this might be wrong, so I'll try and explain it how I dumbed it down in my mind. But you were kind of saying that you're allowed a limit of 1 watt, but they're putting out lots of 1 watts, which would kind of be like if you had, in my world, a 1 watt stereo, it wouldn't make a great deal of noise. But if you had 100 of them all stacked up on top of each other and you turned them all on at once, then obviously you would have quite a lot of noise. Is that a good analogy for what you were describing? Oh, I think we've lost your sound for a second, Jimbo.
Hello, is that better?
Yeah,
okay. Everything that's broadcast and radio transmitters is licensed in Canada, and to allow, because we do own the radio waves and the airs, if you will, To allow the citizen the right to broadcast. They don't license 1 watt transmitters or transceivers. So our modems are supposed to be limited to 1 watt. It's very difficult to get radio licensing for transmitters and stuff. So basically on all these buildings, you see these transceivers, these transmitters, these radio towers that are looking like, I don't know, like the fluorescent neons, but stacked vertically. And for a long time, I don't know what's in them now, but for a long time, they were composed of literally 50 to 100 1 watt alpha modems that work to transmit and broadcast data. It's almost a local network that covers a wide area, and it's been installed on your rooftops. You know, any city you are.
Do you think the technology that you're describing with Google Loon is a rehash? In other words, is it something that's always been there and they're just starting to expose it in a new way so that we're accustomed to it going forward?
Well, I think balloon satellites have been around since probably 1950s.
Yeah, that's kind of what I'm asking.
Yeah, they've been around a long, long time. See, you know, even the word satellite, when you set something alight, like a bird can take a light or go off in the air, you know, it's like playing with words again. You know, you set alight a balloon, you set alight, you know, a bird, a pigeon, whatever. I think it was just one of these, you know, clever Kabbalist word games to reinvent something. I don't know.
You were talking earlier about skip waves and skip wave propagation and how it would differ like on a ball as to like on a flat plane and stuff.
Yeah.
You figured that they could like use like some sort of like skip wave type technology like with a balloon and be able to send it much further, maybe with even like lower wattage.
You know, one of the problems with radio waves is, again, interference, and often distance is related to interference. Most radio towers and transmitters have a limited range. So they use repeater technology. They'll have one talk to another down the road, and then finally arrive at the end. So a lot of things are done through repeaters. If you can't get the wave far enough, you use a repeater station. The repeater will pick up the signal it can and then re-amplify it and rebroadcast it. So that's another way to cover distances, is using repeaters.
I suppose having control of the communications industry is, well, it's highly lucrative for a start. Once you have the hardware in place, then it's all just rental fees, isn't it? You know, for it doesn't cost any more to transmit and receive. Here in Phuket, there's one particular communications mogul who made an absolute fortune. You know, that particular person, I can't remember which country he's from, but you know, he had control of the mobile networks, and yeah, just immensely wealthy from that. Whereas really, it's a service that could be provided for next to nothing. You were talking earlier about getting fined for actually cancelling your contract. I mean, that's just ridiculous. That's just yeah, it's just an example of how the money is.
If I could just say real quick, Nick, to that, like if they are sort of kind of hiding all this information, they're using undersea cables and then telling us that it's all been done with satellites. This is kind of like a way to price fix, you know, all the services.
Well, part of the game is they sell these so-called slots for satellite space up in the orbits, and they say there's a limited number. In theory, you cannot send up your own, quote, communication satellite without giving the $5 billion for that space. So I think it's just a way in the telecommunications game of like shelf space, okay? In the perfume business, you go to an Eaton's or the Bay or one of these chain stores, and you have a new perfume product that you want to sell. Well, guess what? Your shelf space, you're going to have to pay $10,000 or more for, sometimes per store. So it's like the game of shelf space in the retail market.
Right, because the communications industry kind of becomes this telecommunications marketplace. And so what I'm suggesting is that, like, if this is going to go anywhere with this kind of line of conversation, perhaps it could go to, like, you know, maybe making it all free, because essentially it's all paid for itself already. You know, and this was like American, like, taxpayer money to like build the North American infrastructure anyway, and then to like basically seed fund all the companies that, you know, produce all.
Well, they had to introduce it with the supply side. Like, we have a client service infrastructure. Computers are built with master and slave hard drives. Any computer can be a server, but it's just we like only call certain places where you are servers, and then you're the client.
Yeah, I mean, they have the advantage on all the technology, you know, over the citizen, over the layman. They basically have like irrigation that's just placed everywhere, you know, in order to, you know, extend the open market, I guess. That being with like even being able to use like a credit card, you know, in a remote place, you know, they have to have like some kind of signal there to use their infrastructure. So, you know, this is
we're really struggling to hear you. Actually, Snack, you're really quiet. I've turned you up to the maximum as much as I can, but I just want to ask Nick a quick question. In terms of, you said about the media mogul that's making all of his cash off the data communications systems, what's actually sold to the people out there? Is it communication satellites specifically that he's selling to the people?
We're getting electrons moving, and we're buying the right just to move electrons. That's what we get out of it.
Sorry, Jimbo. What I mean is, because Nick's out in Phuket, out there they have very different ideas to us in the Western world about what's giving them these facilities, and I kind of want to know from Nick what's actually on the billboard. Is it a picture of a satellite, so to speak?
Oh, okay. Well, my original point was this particular person who's opened up a big marina in Phuket. He made his fortune from the telecommunications business, basically being the first person to, I suppose, like Jimbo was saying, is, you know, own the network, maybe, and then obviously, you know, the rental fees from that. I'm not particularly sure whether he was actually selling mobile phones or renting out the frequencies or what, but another tycoon who was much more, I mean, in politics, he joined the club, the Western club of elites, and enjoyed a lot of support from the West while he was prime minister. And he set up Thailand's first kind of mobile phone network, and then a satellite, and, you know, again, made an absolute fortune. And I mentioned it the other day, that it turns out that the government is mandated to rent out these frequencies provided by the so-called satellite. And the current prime minister was saying that we don't want to do that anymore because we don't need it. We just don't need these, everything's done with digital transmissions, it's all free to air stuff. In fact, here, all the frequencies are owned by the military. If you want to open up a radio station or something like that, you have to get it off the military, and it's very restricted in the, again, the wattage and how far you can broadcast. I'm working for a local radio station here. It just about gets across the island, which is about 50 square miles or something. Once you beyond, but that's the limitations put on. The mast can only be a certain height, and the frequency, the wattage can only be a certain amount. But yeah, I mean, it still takes a huge amount of power to broadcast. So it's funny when you hear someone tell you that a satellite has about as much power as a car battery or something, yet it's supposed to be able to broadcast these signals to like thousands of households, hundreds of miles away. I mean, again, it's just one of those things where the actual science doesn't add up. Anyway, I'm going off a tangent, but yeah, basically, it was interesting that this former prime minister had a satellite communications company, and then the government is then mandated to rent those frequencies out, but there is absolutely no need whatsoever for them. As we all know, the cables and everything exists. Things can be bounced off the ionosphere, etc. So, must admit though, satellites were the last thing to let go for me when it came to the flat Earth. But there are so many. There's so much real science that can explain how we can communicate across the plane that just makes sense. So yeah, I mean, eventually you just understand that there's no need for them, and it really is just, again, another way of squeezing as much money. I mean, it's like your internet connection, isn't it? You can pay for a low bandwidth or a high bandwidth. They're not coming along and putting extra cables into your house or anything. They're just flicking a switch or pushing a button on a computer and giving you the extra bandwidth. It's already in place. So really, why do we have this tiered system of paying for bandwidth? Because it's already there, really.
Yep. I don't know if we can check if Snack's got his mic back working, if it's any better. Can you just say a few words, Snack, see if we can hear you better? If he's still there. If not, we'll have a few seconds of dead air. But yeah, it is fascinating though. So the concept of satellites is definitely prevalent out in Phuket then, Nick?
Well, I mean, Thailand only has the one, and it's not being used. So apparently it's just floating up there doing nothing. But then it's interesting, you look at the weather radar. There is a radar here on one of the hills in Phuket, and you just look at that, you look at the data it's collecting, and it goes, I think it's about 240 kilometers, the radius of this radar. And of course, it's picking up stuff that should be beyond the curve. So you just look at these things. As far as I've understand, weather radar can reach up to 800 miles. I think that's how they advertise them anyway. These ground-based radars, converting signals into images. And again, why have something that can go that far and bring back information that far away? But logically, you've got to conclude that it can't be going down around a ball. It must be picking up that information from a direct line of sight. Yeah.
I can only assume that with the mainstream of information that's available through the mainstream, that someone like yourself, Jimbo, would also come to the conclusion that satellites are indeed there. Was it the same as Nick? Was it a difficult thing to let go of, or what?
I've actually pointed satellite dishes and stuff, and you know, way back when for amateur radio, there were Oscar satellites, or so they claimed, which were the orbiting satellites for communication by amateur radio. But it doesn't really add up anymore, you know. You know, when you believe something, it's easy to follow the, well, myth, lie, and procedure, and especially if you're getting the result, even though, say, for example, I was pointing at the ionosphere, thinking it was Oscar, the satellite. Then the result wasn't that, you know, I thought, well, it was the ionosphere. My belief at the time was, yeah, that was a bounce in a signal from the satellite. When you're fooled, you're fooled. And the lies that go with the deceit are the truth for you. Like I say, now I know every satellite dish I ever put up, even if they were 2 doors away from each other, you have to look them up and get your angle for skew, direction, and, you know, point them exactly a certain way. Or at the time, that's how it had to be done. Today, I mean, I look all around me, I see satellite dishes that are pointed at buildings, for frick's sake.
Yeah, I've seen
Got
that too.
trees and forests in front of them, and yet they can get the signal. There's something amiss with all that, something askew, and it's not the dish. But anyway,
I'm sure Bob Nodell explained this in terms of if you're using a ground-based, you said it already in terms of the magnitude of amplification based on the watts that you have, and if you can literally barrage the signal, it'll just work its way around everything just by pure brute force. You know, there's no necessity for this weak battery powered, like Nick says. You know, it's running off potentially like a car battery in terms of how much energy it's pulling from those solar panels.
That's basically how FM and AM radio stations work. I mean, you look, the broadcast area, like for Phuket, he says it's around 50 miles around, and that's on probably 50,000 to 70,000 watts of power to get signal to, you know, a small area. And you look at any local FM or AM radio station, they're not broadcasting very far, and they're taking in the thousands of watts. In fact, I think they use more distribution wattage in the daytime and less at night because there's less interference, less noise. So they can save 20, 30,000 watts in the night and reduce their output wattage and still get signal to everybody. In fact, at nighttime, some radio stations, it don't matter where they are, you'll pick them up halfway around the world. It don't matter if they're an AM station in the USA, you might very well pick them up in England or France or almost anywhere, literally. So there's something happens at nighttime, allows radio waves, AM especially, to travel thousands of miles.
Sorry, what were you going to say, Nick?
Yeah, you often hear from amateur radio operators that they've bounced, or they're often very proud if they've been able to bounce the signal off the moon. And, well, I just wanted to hear your opinion, Jimbo, on...
As long as you believe it, it's absolutely true, because I know about the moon bounce. Yes, amateur radio enthusiasts are proud when they do, you know, one of two things, certainly, well, three things. Contact to every contact or every country on Earth, because some people keep a file of all their contacts. Another one is the moon bounce. And the third is at the rallies, when you go and you have get-togethers on these mountaintops. People bring up little mortars, turn them into generators, and the challenge is to transmit with 1 watt halfway around the world. So, and that's a big challenge. It doesn't happen every time there's meetings, but the goal is to transmit halfway around the world with 1 watt of power. The other, again, the moon bounce, and then the final one, a contact with someone from every country on Earth. Those are,
wow. So, okay, so yeah, I mean, you can imagine the drive, the excitement that would So, I mean, if someone is claiming that they have bounced a signal off the moon, what do you think? Is that something that is possible?
Like me, I would have truly believed it. Today, my own belief on the moon is it's a reflection. It has no mass. It is just like the Chinese magic mirror in my book. We never see the backside. It whips around like it weighs nothing, you know. It probably does weigh nothing. But no, if it's just a light, well, how do you bounce a radio signal off more lights?
Absolutely. Yeah.
Certainly in their hearts, like I would, and I did believe what I did was real then, and that all the lies that went with it were the truth. Today is different. So the people who believe they've done, as amateur radio enthusiasts, a moon bounce, they truly believe it.
Well, this is a really interesting
point. It doesn't make it so.
Well, exactly. This is a very interesting point on account of the fact that when people are talking about flat Earth, they say, well, not all these people could be lying. And the assumption is that when somebody, if I tell my nephew about how the heliocentric model works before flat Earth, as I have done, that I am intentionally perpetrating a deception when I do so. And in the case of understanding how a deception is perpetrated, along that path, you realize that the people who are telling you the false information are in no way intentionally trying to lead you along a path that's incorrect. In the same way as when you were bouncing stuff off the ionosphere, contacting people around the world, your understanding of how the mechanics of that are functioning are such that you are cemented with this idea of a globe. And when you describe it to your friends in everyday conversation, or if you're talking about the signal you're getting from a geosynchronous satellite, again, your terms that you will use when you phrase this to anybody else will be part of that system that that perpetrates deception. But you are not actually a liar. Therefore, as a whole, it's not like everyone at NASA or everyone who's talking about being on a globe is a liar or trying intentionally to deceive people. That's simply not the case. And you learn that as you realize how you have also perpetrated parts of this deception unintentionally.
They were only repeating what they truly believed, just like I did for years. I truly believed like what I was taught. The sun was 93 million miles away, the moon 250,000, the stars light years away, and we were potentially looking at stars that were dead and just seeing the light that remained from them. I believed all that crap and repeated it over and over. I grew up on science fiction, you know, but I had the advantage that I learned a lot about practicality, you know. If you really can't touch it, feel it, sniff it, shoot it, fuck it, whatever, I don't care. But
it's got to be verified. I'm sorry to
be verifiable.
We've just been joined by Anthony Riley, so I just wanted to say a quick hello. He's on mute at the moment. Hopefully he's can pop off mute and say hello. How you doing, Anthony?
Hi, he's good, man. I've been out seeing the family this Arvo, so we've had to go and do a birthday afternoon tea with a 71-year-old. I've only just got your message as I walked in, so I thought I'll flick in, see if he's still on. So just checking in.
It's very good to have you here. Have you been keeping up with the conversation a little bit, or have you literally just joined?
No, literally just walked in now. I've just blind walked in, so whatever previous was, I've not seen or heard any of it.
I'll give you a quick summary, just because I feel it's worth it, purely because you only just joined. So we're saying about finding out information that is akin to a deception that works. In other words, Jimbo has done things that are or could be used or attributed to proof of there being a globe, or proof of there being satellites, or proof of whatever you like that isn't necessarily true when you study it a bit more in depth. So it's finding out that everybody isn't lying to you, but plenty of people are misled in their information and therefore inadvertently perpetrating deception. There you go. That's hopefully a decent enough summary.
Yeah, I think ultimately it comes back to what level of evidence do you accept before you make your decision, whichever way you go. And some of us have got a low level of threshold that of stuff that we consider to be acceptable. Others have much higher. And ultimately, it's about what standard of proof do you accept. And there are stuff out there that's weak that people do accept and don't challenge. But equally, there's stuff out there that's very strong, which people reject. And it's not necessarily true to say you should be rejecting it. You should be taking it with some consideration. But overall, I mean, there's no easy ways around this. I was discussing this with someone today. You have to be quite intelligent to work out what is good evidence over what's bad evidence, and it's not that easy to work it out. You have to kind of accumulate everything all in one kind of pot for a particular issue, and then you've got to make your own decision. And you can be lied to. You know, there's not all evidence is good evidence, and you've got to try and work it out yourself.
But you have to be one of those people who is looking into the evidence, because if you're not, then it's all fact, and it just, you know, rolls on.
And indeed, if you're not looking for the evidence and you see a contradiction in the evidence, but you don't realize it's a contradiction, you kind of say to yourself, hey, shit, that doesn't make any sense. But you just think, oh, it's because of me being thick for whatever reason. There must be an explanation. I just know about it. So you ignore it and don't challenge it. But it's only when you realize, hang on a minute. And then you find one of your close circle of friends is maybe looking at something similar, and you find out about it, and you're like, do you know, I've been thinking about that for ages. How did you get into it? And then you start looking into it because you realize that somebody else is doing it too. But until that happens, you can live your life looking down the tunnel like a racehorse on a racetrack with the blinkers on, and not realize that you're racing a race with another 15 horses. And you just don't realize what else is going on around you. Main things are the distractions of life in general, like money, work, family commitments. I mean, if you've got enough distraction in your life, the whole world can move around you, and you wouldn't even realize.
That's a very good point, man. Yeah.
Yeah, I left the dead air because of how good a point it was. You're absolutely right.
Yeah. Yeah.
Well, it's like some of the old, I don't know what you call them, adages or whatever, but like if something sounds too good to be true, it probably is. And most of what NASA sells us is too good to be true. You know, here we know, like, you know, to transmit from a radio broadcast tower 50 miles around, it takes 70,000 watts. That's for 50 miles around. Okay. Now, here you have NASA claiming to have sent a 10-year mission to Phobos asteroid or whatever it was, billion a mile or more away. I don't know how far away it was, 10 years out. Now, it's supposed to wake up from its sleep, take some pictures, and somehow a radio transmitter sends back a signal from a 10-year dead cruise out into outer space, point it directly back at the Earth, and we get to receive all of these datagrams and put together pictures of this comet more than 10 years away at thousands of miles an hour, and, you know, all that nonsense. Same thing when it comes to Pluto, 1 billion miles away. 1 billion miles. It takes, like, I don't know, at Phuket World, that radio transmitter for 50 square miles probably runs at, my guess, 50,000 watts daytime broadcasting. You know, that's 50,000 watts to cover 50 miles. We're talking billions of miles on a how many watt transmitter that sent back these signals from Phobos, that sent back these signals from Pluto, and through noise, through the ionosphere, through the Van Allen radiation belt, which is highly ionic and static, through 20 million electron volts of atmosphere back down to Earth to a receiver. Oh, we got it. We got our signal from the Phobos mission. Oh, we got our signal from the Pluto mission. Who's kidding who? You see, I mean, you know, it's easy to believe if you don't know, like, you know, some of the technical values involved. Like I say, if it takes 50,000 watts to transmit to people 50 miles away, then, I mean, multiply that by the billions of miles away that these little probes are. That's how much power you'd need to retransmit back. And you'd have to get the direction right, too, because not all antennas broadcast, you know, in omnidirectional or even directional. How do you point your damn antenna?
You're
what
absolutely
kind of
right.
antenna did it have?
You're absolutely right. The power that's needed just to get back 240,000 miles from the moon is astronomical. And what creates the power? What power plant do they have there that can actually do this? Oh, but there's no atmosphere, so you don't really need that much power. You do, because it's distance. It's not to do with what's in the way. It's to do with the distance involved. It needs to be powerful because you've got to push it. No one gets it. No, everyone.
Look how easy it was for these guys to set up their little dish antennas on the rover, just driving around everywhere with a little dish antenna on it. Capsule lands on the moon and it's got a little dish antenna on the side. I mean, what did they have? Radio Shack, satellite detector, and to hone in on a beam or something. It's a joke. They were upside down umbrellas mounted on little rods with clamps.
You can't understate the importance of the angle or the orientation of the dish when you're firing the signal back, because whoever calculates the angle that's necessary for the signal to receive, and once you've sent that signal, the time it takes for it to apparently get back to Earth, unless the Earth's in exactly the right position, the dish is ready.
I've got to interrupt. I'm really sorry. I'm so sorry. But it wasn't from the rover. It wasn't transmitting to Earth. It was it was going up to the orbiter, and then that was transmitting to Earth. So that did have significantly more power. And again, to give balance, that was playing devil's advocate. I'm really sorry.
No worries, it's fine.
One bank of batteries that they'd driven the thing round on, and it was the same bank of batteries that they used for your umbrella.
I'm thinking specifically, like the Voyager 1 and the Voyager 2. I mean, yeah, okay, they're running on plutonium apparently, and they're still transmitting now, and they've gone way beyond Pluto. They're out of our solar system apparently, and they're still transmitting. And I'm thinking, how does the orbital mechanics work on that? Because once you get that far, not even that far away, you only need to be a couple of miles away, but you can miss your signal with a couple of degrees off and it's gone. So how do they actually physically orientate the thing that's sending the signal back to pulse the information, and then the Earth just happened to be in the right place? It's ridiculous. It is.
Well, that's an interesting one, because that has a what they're claiming is an actual picture of Earth from space in it. I mean, obviously you've got the full blue marble picture, but you've also got the picture that Voyager sent back, and it's got the Earth and then the moon directly behind it. So obviously it could be much further out, but according to their picture, it's just peeking its head behind the Earth. But technically speaking, that is a picture of Earth from space. That's not a composite or anything of that nature. It's just a photo from Voyager. But it doesn't get much attention. I mean, it was one of the first things I made a video about because Vsauce highlighted it. But there we go. It's just a picture of Earth from space, which I thought was quite interesting.
It may well be a picture from space, but what's it a picture of? Because they tell us it's a picture of Earth, but it could just be a bit of dust on the table that we can't tell the difference. I mean, how do we know it really? I mean, it's not. It's preposterous. Nothing can be that far away, because it doesn't. There is no such thing as deep space the way they're describing it, in my opinion.
I agree.
Yeah. Of course, then there's the other thing of does if there is a vacuum, as they claim, which I don't believe there is, can signals be transmitted through a vacuum? Jimbo did address it earlier on, but that's just one of those.
I couldn't say for sure. I don't know for sure. They should be able to go through a vacuum. Heat can go through a vacuum.
I'll tell you a good moot point to discuss. When the helium balloons, the weather balloons, go up into as high as they go, 110, 120, 122,000 feet. When they get to that point where they burst, it's interesting that the science behind why the balloon bursts, because I've heard different stories or different accounts for why the balloon bursts. Is it because the vacuum of space is pulling the balloon apart, or is it because the helium inside has expanded to the point where it can no longer expand the material and it bursts from the inside? What is it that makes the balloon burst? Is it pulled apart from space? Or
it's going up to the jet stream levels. Jet streams run at 300 miles an hour. If a stream of air hits something that comes into contact with it, it can tear it. It can rip it. Who's to say it's not hitting a jet stream and getting torn apart by the jet stream?
Indeed, I mean, it would be good science if we could either work it out because we need a pressure, a pressure relief valve or a pressure sensor in the balloon, so we could get that telemetry to know whether the pressure was going up or down inside the balloon.
You need to track a good aneroid barometer up with the cameras and other equipment to measure air pressures at 100,000 feet accurately.
I'd just like to know whether I don't believe that deep space is the way they say, but I'd like to believe that there might be some kind of difference up there in terms of the pressure that makes it at least viable, that it could be the case that there is space there, because I'd like the idea that it was the vacuum that pulled it apart. I'm not saying it is that at all, but I'd like to know what makes the balloon burst, because they all do it. They all burst. They all do that. I just want to know how, why.
can explain that. I mean, the balloon's going up and it's got less and less pressure on it, right? Simple.
We don't know that for sure, though. And what if it hit a really frozen surface, really cold? Shatters almost anything. Plastics become brittle. Shatter. Freeze stuff.
Would you not say we can extrapolate it from what we do see in terms of it going up and getting bigger and bigger and bigger, which would suggest that there's less and less pressure placed on the outside of the balloon?
It could be from heat. You expand the gas with the heat. If the sun is hitting it, the gas is going to expand. Balloons go up and down. NASA's balloons and all these balloons, they have a day cycle, night cycle. They rise during the day and they sink again a few thousand feet at night and re-raise again the next time the sun hits them.
Well, all we know is
that
when NASA
could be pressure, could be heat, could be thermal.
All we know is that when NASA set their balloons up, they go up very deflated. There's just enough helium in them to get them to move. And obviously, eventually, I don't know whether NASA balloons burst, but there's 3 causes for the burst, in my view. There may be more. I hadn't thought of the extreme heats either way. But ultimately, the balloon seems to either gain a lot of pressure on the inside and bursts it from the inside. It gets sucked from the outside, which could be a vacuum of space, or something else happens altogether. But it's always around about that 120,000 feet. But that's where we should focus our attention. Get a pressure switch in there to find out what the pressure is all the way through the journey. Does it go up or down? A temperature inside the balloon is something we could do with checking as well, because that's an important factor.
It could be electrical, the cause of the demise of the balloons too. Almost like lightning.
I was going to say that seems likely. Actually, I would say that seems more likely. As you're going up in height, you're gaining more and more electricity, to keep it in simple terms. So why not?
If it forms a capacitor because it's charged on the outside, not the inside, the surface of the balloon, the capacitors, like they burn out, they short out, they burst. It could be any number of things. It calls for speculation. Like I say, it could be the cold, a shear, it could be heat from expansion, and it could be electrical.
I honestly think that's where, I mean, we can do the helium balloon experiments. We should be focusing on these kind of things, because if we find out that the temperature inside the balloon gets really, really hot, that'll be interesting to know what makes it do that. But conversely, if we find out that temperature drops through the floor, and the balloon still bursts, it's like, well, how do you interpret that? So to answer your question before, Nathan, can we not extrapolate that? No, I don't think we can, because we need to rule out things that it's not. Then we could probably extrapolate it, but we need more info. But then again, this is where you have to question the science, because this information is already known by NASA. NASA know this, and they just wouldn't ever tell us, even though they're funded by the public's purse. So that we are owed this information, but they're never going to tell us, because it'll probably open the door to a lot more questions than the one answer that they're going to give us. I mean, it could be the case that it's to do with the heat, but if they said that, then we'll say, well, where's the heat come from? Or it's an electrical charge. Well, where does that electrical charge come from?
Because I remember one balloon flight they sent up, I guess it was the New Jersey school or something on the East Coast. They had a thermometer, everything, electronic thermometer. And when it got to a certain height, it was over minus 100+ degrees. Now, I don't know plastics well enough to know their behavior at minus 100 degrees, but my guess is they become very brittle, hard, and shatter. So, I mean, turns into glass.
It makes me think of the propaganda for Roswell, New Mexico, and what they showed you on the pictures was like a balloon, but more brittle. So that immediately rings bells.
And it gets damaged too. Sometimes things freeze; they're not the same after. Some plastics, if you freeze them, they'll stay brittle even when they're come back to room temperature or whatever. It changes them molecularly. It's hard to say.
Yeah, and these are things that we could find out if we knew that people were planning on doing balloon experiments again. Because I mean, how hard is it to put a thermometer inside the balloon? We don't.
And a little manometer, a little spinny thing that indicates like a wind vane, just the direction and speed of the wind.
Yeah. Isn't it crazy though that we should even be having this conversation, because this information like is clearly known by science? I
wish
may be ignorant.
Someone would put a little gyro stabilization on a balloon someday instead of having them flinging and flurling and just twirling and just freaking nausea cams. $5,000 nausea cam, for Christ's sake.
I think it's interesting that they all seem to get to around about that same altitude of around about 120-ish, give or take a little bit, because something seems to happen at that point where we don't seem to be able to get past it. But that's where the real science is for us guys, because we can do this without spending too much money.
Talking of spending very little money, Zach Zabala's off the hook today because I got that video back. Somebody fortunately mirrored it and I was able to put it back up. So he's gone out and got drunk last night instead of having to do the interview again, which is good news for him. He may join. I've sent him the link, but he has done exactly that. He's replicated, to change the subject, curvature on a flat surface. And yesterday evening, I presented this to a few of the flat Earth detractors, and they had pretty, poor answers for it, to say that maybe it's not flat enough, the level of the surface he was shooting over and things of that nature. But it's a topic I want to discuss a bit more. So I know you're itching to do the same. So yeah, go ahead.
Well, I do have something I can add to this if you want to share my screen. I have a flatty friend. He's a chemist by profession, but he's well into the flat Earth argument, and he's obviously a baller because he's a chemist by trade. But he challenged me, and I agreed to do it, and I haven't yet done it. But he challenged me to repeat the experiment with what Zach did, but change two variables. One was the shutter speed, and the other one was the aperture, because he believes that the aperture and the shutter speed influence that which we see. And I was like, okay, well, we'll do it. I'll put a video up next couple of days. And I never got around to doing it. And my intention is still to do it. But in the meantime, he sent me his photos. And if I can go through the photos with you, it's really quick and easy to do. He does replicate that which Zach shows. But on the one hand, he shows that it can be done. But on the other hand, it kind of proves that it can't be done by the same sense, because to be able to do this means that you've got to be playing around with your camera whilst you're trying to actually get something in focus. And there's no way that anybody would do that. I mean, you'd have to be an absolute smoke and mirrors master to be able to do this in the real world whilst you're doing this experiment. But if I can show you his photos, and you'll see what I mean by the alterations he's made. To be fair, it's really good evidence, and it's going to make me think about what we're looking at next time I do my own observations, because I'm going to try and get the variations that he's got using aperture. I mean, the shutter speed's not relevant when you're doing time lapse, but the aperture setting is really important if what he says is possibly true, because it may cause the horizon to artificially rise. So if I'll stick myself on screen share, if you could just thingy me, if you would, Nathan.
Yeah, you're screen sharing.
All right, this is the guy's setup. He's done it in his, I think he's done it, I don't know if it's his bedroom or if it's his university pad or whatever, but you can see the cameras on the left, and like he's recreated the experiment, as you see. Now, my observation at this point is that he hasn't really done any distance on it. He's just done it close up, but that's cool. That's cool. He's trying to show that changing the aperture can influence the results. And you can see he's done it on a Canon lens. It's a 50mm, a nifty 50, on a 1.4. And then basically he then shows it at 15 centimeters away. And I think this one is changing the speed of the shutter. So if you notice the horizon below the horizon, that which would be the sea, you can see that it's varying slightly. And I think this one, these photos, I'm going back now towards the beginning, but these photos are all showing that the shutter speed is altering what we see, which is a fair point. Now, if I go to the one where he changes the aperture, this is the one that's interesting. At 60 degrees, I think this is the one that he does the aperture. 60 centimeters away. He's varying the aperture on the photos. I've checked the metadata on the photos, and the aperture is changing. And what this is showing is, you may not be able to see it on the screen, but his first photo makes this the table edge completely in focus. But what he's saying is that when this becomes out of focus by changing your aperture, we get that false horizon rising up the buildings. So you can see on this next picture, it's not really there on the next picture, but now it's there, and now it's there more. I mean, it's literally right at the bottom of the right at the very bottom of the buildings down here. So what he's successfully showing, to be fair, may well explain what we're seeing. But that doesn't mean that it was fake, it was fraudulent evidence in the first place by Zach. It just means that if this is an explanation, doesn't mean it's right or wrong. It just means this could explain what we see. But again, it doesn't mean that it does. So it could be the case that we're getting this regardless of the aperture setting when we're looking at 30 miles. So it's not conclusive, but it's certainly suggestive and persuasive. And on that basis, I'm prepared to do variations on the camera settings to negate this or to confirm this, because if we are seeing the horizon rise up because of aperture settings, we need to know this because it is important. So kudos there to GeoStreamer. He's actually done something good this time, even though he disagrees with me on everything else that I do. It is good evidence to show that aperture at least does influence what we see when we're taking the photos. So I just thought I'd share that with you guys and see what you think.
Very cool. Very cool. What do you make of that, Nick?
Yeah, it is good to test that kind of thing. And obviously we're often dealing with cameras and optical equipment, which works in the same way as the human eye, to make these observations. And of course, but then if we talk about the human eye, what's actually going on there? Even when we look at an image created by a camera or a telescope, how is our eye or our eyes interpreting that?
Well, he's eliminated one of the most important variables to there, which is the lensing effect from the atmosphere, which is totally out of the equation now. So how does it prove? You know, even if it does show that some missing land may be from the aperture and the setting of the aperture, or the base of some buildings or some fog at the base, it takes away one of the really important questions, is the atmospheric lensing.
Absolutely.
That was the key question. And he's eliminated that and said, look, changing your aperture gives you this effect.
No, I agree, absolutely. It doesn't prove that what we're seeing is what he's created, but it does raise the question that does the camera settings make much difference? Now, the shutter speed won't make any difference on the long exposure, but the aperture may. Not will, may. Now, he's illustrated it, and we'll consider it. I'll consider it when we do the next experiment, the next observations. But it's by no means a victory, because we don't have the edge that he has of his table when we're doing the experiment. We have the plane floor, or the plane of what we're looking across. So there is no edge to get out of focus, whereas he's showing the edge on his table. That doesn't exist in real life. So there's a hard edge there that he's got out of focus. So that's it's a weakness, not a weakness, but a criticism of the observation he's done.
Well, the depth of field, depth of focus, obviously you can play with too. But again, he's taken out one of the key elements, which is part of the question. So it voids what he's doing, in the sense that without the atmospheric lensing in the equation, it's still a good example he's giving. I agree. But again, the question is how the atmospheric lensing, how all this water in the air creates, magnification of objects at the distance.
Yeah. And obviously this is when we get into standard refraction. And I just want to say something about standard refraction. It's been a bit of a pet hate for me whilst I've been doing these observations, because standard refraction is being argued by the ballers on all of my observations, saying, oh, well, it's just standard refraction. And it's like, no, hang on a minute. You can't have standard refraction when we're observing buildings that we shouldn't be seeing, if you're not going to allow for standard refraction with things like boats going over the horizon, because you can't have it both ways. Either standard refraction is a thing and it affects boats going over the horizon, or it's not a thing and therefore the Earth must be flat because there is no perceived curvature when there should be. The math doesn't seem to verify up. So, but when I asked Mick West about standard refraction, and I asked him, on what evidence did you use or base your standard refraction claim on? He claims that it's the stars in the sky appear to slow down as they go towards the horizon. Now, I don't live in an area where I can test this, but if the stars, if what he says is true, and I don't accept it's true at all, but if the stars do seem to slow down as they go towards the horizon, they will also change the angle, the arc that they make. And there's no evidence that they do anything like that at all. But to be fair, I've only seen evidence that they get bleached out by the light pollution. But if he's going to argue that standard refraction is a thing, then standard refraction applies equally both ways. Sometimes the building you're looking at will be above the horizon, other times it'll be gone. But I don't seem to be seeing that. It always seems to be there when I'm expecting it to be there. But secondly, when the boats go over the horizon, they must be subject to the standard refraction too, and that can be used by by flatties to explain why sometimes it appears that the boats are disappearing from the bottom side up. Lensing is an issue as well. But I just want people to realize that this standard refraction rhetoric that is out there by Mick West on the Metabunk website is absolute bullshit. Pardon my French, but it's complete folly. Nobody should accept it as truth because it doesn't do what they say it does when you do any of these observations in the real world.
Well, the only true reason for the existence of the globe as an ocean is cherry picking of, you know, fallacies. And that's why we have a globe.
Absolutely. I honestly believe these southern stars, when these get brought up, as they always do, I actually now believe that the rotation of the southern stars that seems to match the northern stars is probably where they got all the distances from, because I've read one of the questions you have to ask yourself is, how do they know how far away the sun is? How do they know how far away the moon is? And they say, oh, well, NASA have been there. And like, yeah, but you have to calculate the fuel and all that. How did they do that? Based on what mathematics? And apparently it comes from a Mars bit of parallax, which may or may not be true. But I actually think that the reason why they calculated the circumference of the Earth is based on the two variables that they knew that we would find out eventually, which is the southern star rotation point and the northern star rotation point. And they're going to use that to make the circumference of the ball, or half the circumference of the ball. And that's where I'm sure all the maths has actually come from. They've known about the rotation of the stars years and years and years ago. We've only recently found out about it. And that's for me, that's where they get all the maths on. That's what I think they've based all the maths on.
I was going to ask Nick, I assume you get different star constellations there than you do in the UK, and you've done lots of videos on, well, the moon and the sun, but do you observe the stars much down there?
Yeah, I'm quite fortunate actually, because being on an island and close to the coast, I don't get too much light pollution, and yeah, I see the same stars going overhead for the most part of the year. From where I am right now, I can't see it, but I used to be able to see Polaris quite close to the horizon, and I can see the Southern Cross. So yeah, I see them all come across, and it just becomes very, very frustrating, you know, with dealing with people defending the globe. You know, you can understand their passion. You know, they look at the stars and they get familiar with them. I'm sure it's the same for a lot of flat earthers. You know, you didn't maybe look at the moon. You might see the moon, or you might occasionally notice, oh, there's the moon in the daytime. But maybe, you know, a lot of the time we didn't spend much time actually observing it. But yeah, when you really think about it and look at them, you just see, well, personally, I feel that they're very, very close. And your original question was, you know, what do I see? I see things like the Big Dipper and Orion, and yeah, Venus pops up in the evening and in the morning.
Nick, what's your latitude, my friend?
7
what?
7
North?
degrees, I think. Hang on, just a second. I've got to look this. Oh, I'm in opera. I've got to look this up.
Because I was talking about you recently with regard to observing Polaris and Sigma Octantis. You're in a brilliant position. Are you actually able to see the constellation Octantis?
Right. Sorry, am I able to see the constellation?
Are you able to see Octantis?
The Southern Cross, yeah.
Well, you know, you got Sigma, the star, what they call the Southern Pole star that we can't see, and then you got Octantis that goes around the outside of it.
Right.
Are you able to see that from your position?
Yeah.
7 degrees north.
Hang on, what am I? Yeah. Latitude and longitude. 7. I'm sorry. Yeah, 7. 7 degrees and 98.
7 degrees north, right?
Yeah.
So in theory, if we live on a ball, there is no way you should be able to see the constellation Octantis.
Hmm.
Because you'd be looking through the curve of the Earth.
Yeah.
Yeah, that's correct.
Yeah, exactly. That's the thing, But of course, you try to argue this point with a baller, and of course, the whole perspective thing is just not there in their head. And I've been through this so many times; it just becomes silly.
Hang on. Let's just clear something up. You're at 7 degrees north, and Octantis. If we live on a ball, I mean, how much would you allow in terms of degrees before you say you should not be able to see Octantis? Because if Octantis is not visible, say 2 degrees north, then that supports the ball Earth. But if it's 1 degree and you can see it, you could say maybe standard refraction. But if you're at 7 degrees north and if you can prove that you can see Octantis, isn't that disproving the ball? Absolutely. There's no science that can prove anything other than the ball does not exist at 7 degrees north if you can see Octantis.
Yeah.
Do you see it on the horizon?
No, I mean, I can't. It's difficult to describe how I see it, but I mean, okay. For example, Polaris is just above the horizon.
Yeah.
But I see it. I mean, it depends on the time of night, right? I mean, I see it coming across.
Yeah, but you see it coming across. Come on, Nick. You're not sounding sure here, man.
No, but you see, I mean, I'm people show us star trails of the south, and I don't see any kind of circular motion at all, right? I mean, I'm just seeing the stars come across the sky. Yeah. So,
right, hang on. So you don't see the southern star rotation from your position at all?
It doesn't look like rotation to me. No, it's coming kind of
right. So if I was a baller, I would argue that you're not in the right position to see it then, because you mustn't be looking in the right place.
Right. I know. Yeah. Mm-hmm. Mm-hmm.
So isn't it a slam dunk then if you can prove that you're looking at Octantis? Now let's just be clear on what Octantis is. Octantis is supposed to be the 4 stars that go around the pole star, which is Sigma. We can't see Sigma, but Octantis is the stars that go around it, and they're in very close proximity. If you could show that at 7 degrees north, and it sits anywhere near the horizon, that goes against the ball Earth completely. There's no coming back from that. If it was 1 or 2 degrees, then you could argue standard refraction maybe, but if you can see Octantis, then that's black and white proof that we don't live on a ball.
Okay. Well, Nathan, that's my next project then.
Nathan, am I right?
Yeah, I mean it's a similar principle to what we showed on the first sun tracking event, in the respect that if you can see the sun from here and you can also simultaneously see it from the other side of the ball, then you can't physically look through the ball, therefore ball debunked. So yes, I mean I wholeheartedly agree with you, and have demonstrated it live, but not with the stars, but with the sun. And that's on the premise, we must stress this, that we're using their maths, we're using what they say the stars are, i.e. they are this infinite distance away, we are on a ball spinning, flying through space. So we're basing this on the presupposition that we are on a ball, and these things that we observe in the sky are the distances that they say they are. And based on what we can actually see, or what Nick literally observes with his own 2 eyes, that's not how it works, because we can see things that effectively should have vast amounts of Earth in the way of seeing them, and they're not.
Yeah, agreed. So, Nick, have you got a P900?
No, I've got it's a Sony Handycam, which is getting very, very old now. I use it every day.
I think we need to burden Nick with the weight around the neck of proving that you can see Octantis, because if you can prove that you can see Octantis at any point in the night sky at 7 degrees north, that you're looking through the curve of the Earth, that should not happen.
Well, someone pointed out to me once when I did my sky grid video, I did some time exposures of the night sky, and yeah, people from Australia and New Zealand were saying, yeah, you're seeing the same stuff that I see.
Nick, have you got Constellarium on your computer?
I've got Stellarium.
Stellarium, yeah, that's
share it. I don't have it to hand, but if Nick can share it, I can present Nick.
It's going to eat up.
Don't worry. What was the point you were going to make, Anthony?
Well, that's their go-to model, isn't it? They use Stellarium to show, because it apparently represents reality. So at least if we could go on to Stellarium and see what Nick should be seeing, then at least people at home or people watching are at least familiar with what he should be seeing. And then if we burden him with the debt of trying to prove that this is not what we see, or that it's different in some way, or indeed that Octantis is actually there when it's not meant to be there, I mean, how would ball earthers get past that?
I think you're right, but I'd rather actually present it when we've got both sides of the argument. In other words, if I just present Stellarium, which I'm totally unfamiliar with anyway on this computer, it may be the case that we're just leaving one side of the argument out there hanging. So, you know, if Nick was to do that, don't get me wrong, I'd love to present both sides of the argument simultaneously, show what Stellarium shows and show what Nick has actually photographed. But that might be for another time. But I'm glad you've explained it, because at least now your point's clear. And yeah, I think you're right. I mean, what potentially we could show is a contradiction. And when I want to actually reference something that has been done in the past, it would be the first sun tracking event, because it did show that on 4 occasions throughout the 2 events. So on 2 separate occasions on both events, so 4 times in total, there were times when the sun, on the presupposition that it is a vast distance away from the Earth, was visible from 2 points on the Earth that it should not be visible. So that could be referenced. But yeah, I mean, hopefully Nick will just say, yeah, sure, I'll see if I can get a picture of it with my my handy cam on a tripod. But going by what he's just said, I don't know. His 1990s camera might not cut it.
Go on.
Let me put it in the flat earthers context. I've got the you know, the northern planisphere. I've got access to a northern planisphere, and on that it tells us that yes, you should see it, but it would be traversing the night sky, like it would be going almost horizontal. There wouldn't be the rotation point like you've just described, because you said you don't see the rotation point, you see it as lines. Is that did I understand you right when you said that?
Yeah, correct. I'm just literally. Obviously, you know, I see a lot of the stars come overhead, but they are just, literally traveling overhead. I don't see them doing any kind of curving or
like Polaris style rotation.
No, I don't. I just don't see that kind of rotation. I just see them.
Could I speculate that it could be standard refraction?
I would give that up to 1 or 2 degrees, but not 7.
Fair enough.
Yeah. Okay. Interesting. I mean, I'll certainly look into seeing what I can do about that. It might take some time, but
yeah,
okay,
that's cool. Just as long as you, I mean, I don't know. Have you ever played with the planisphere, the northern hemisphere planisphere? I know they're slightly different to the southern ones, but it's a moot point. But the northern planisphere shows what you've just described. Yes, you can see Octantis, but it's quite low on the horizon and it moves across the sky, but almost horizontally. It's not a perfect horizontal line, but it's certainly not the center point of a bullseye, which is what the Ball Earth model is based on. That tells us that apparently it's a bullseye and all the stars move around it in concentric circles like they do on Polaris. But on the planisphere, it says, no, it should be low on the horizon, and it travels across the night sky virtually in a straight line. And that's what I believe you see. And it'd be really cool if I could hook you up. Nick, I need to get in touch with you after this, because there's a guy that really wants you to do this experiment. That he's a YouTuber. He puts videos up, and he needs someone that can be close enough to the equator that just happens to be in the Goldilocks zone that you live in to tell him what you see.
Okay.
Oh man, this is gold find.
All right, cool. Nathan's got my Skype. He can pass it on to you. Give you permission. Nathan,
happy days. That's grand. This is going to be an interesting conversation tonight.
Yeah, Yeah, I mean, again, you know, for me, once perspective, you know, became apparent, that's just, you know, that's how I see it. I haven't focused too much on. I mean, I know I've done videos, etc., about the stars, but I haven't focused too much on, you know, really. Oh God, sorry, my dogs are going crazy. Plotting everything. But yeah, happy to do what I can there. I'll mute. Well, let the dog shut up. Let someone else talk.
Sure. I just noticed in chat, Kara said that you can see the tip of the constellation Octans from 7 degrees north. Yeah, I reckon that you would see the tip of it. But I think that he sees the whole of it. I think Octans is 3 stars now. Originally, it was 4, apparently, according to history. But I think that he'll see all 4 stars or all 3 stars of Octans, Octans from 7 degrees north. So if we can establish that he can actually see all 3 or all 4 at any one time, I'm sorry, Kara, but that kind of totally goes against your Ball Earth belief. It's 3 stars. It is 3 stars now, Kara, but it was originally 4. If you look in the history books, it was originally described as 4 stars, but there now only appears to be 3. Yeah, Kara's asking us to try, so we need to do this, Nick. If you're good with it, let's get it sorted and let's present the evidence we find and see where it lies. Because at 7 degrees north, there is no way you should be seeing Octans. Maybe 1 star of it as it rotates around this apparent rotation point, but certainly not all 3 or 4 stars of it. It should not be visible.
Right. Okay. Cool.
Cool.
Yeah. But again, you know, it's some, you know, after doing all these things and you always get the same. Yeah, we were talking about it earlier. You know, you get to a point where you've shown how these things are impossible on a ball, and they either way, you know, they're not going to accept it. We're always preaching to the converted. You know.
Yeah. Listen to Kara's comment. She said, I know that you can't see it. It's a fact of astronomy, and hundreds of thousands of people would have noticed by now if it was wrong. Well, bearing in mind that hundreds of thousands of people are not at 7 degrees north, Kara, it's unlikely that they would notice it. And of them people, how many have got telescopes and are even looking for it? You presented with the evidence. You lived your life with the evidence that you presented with. If you didn't realize it was contentious, why would anybody notice? Let's just try and verify and validate this claim. Because I believe that the Octans would not be visible at 7 degrees. You might get 1 star of it, and even if you allow for bendy light, standard refraction, you may see a little bit of it, but you're certainly not going to see all 3 or 4 stars. And I think you'll see the 3. I think you'll see the lot, and it'll be on the horizon, and it's supposed to travel around this curve that all the stars go around. But I think it'll be traveling in a straight line. Anyway, let's change it a bit now because I've milked it enough and I've hogged enough of the mic. So let's do something else.
Well, I was going to go over to Snack to do some shout outs, but I don't know if he's actually in front of his mic or not. He's on mute at the moment, so if he isn't, I might do some shout outs. I'll pop the chat back up as it feeds through and do some shout outs. How's it going in the chat? Hopefully you're all enjoying the show. Shout out to Dearth and MG42 Pillbox, Jerry Cthulhu, how you doing? Kara, who's getting talked about a lot. John Watson, how you doing? Ian Tinsley, shout out to you, my friend. Pure Anarchy, hello, good to see you. How do you say this? MT, what was it? REDUX. Hello, how you doing? Curve Water, pleased to see you. Shruminati, lighten up on the spam, my friend, please, for the love of God. Kara again. That's we got Level Kumo. How are you doing? Captain Bullshit, pleased to see you. Mark Taylor, same to you. Good to have you here, my friend. Skyfly Bry, I saw you the other day chatting. Good to hear you on air, my friend. Good to hear some of your views. Last night, I think it was. I think we're starting to see a few of the people come through again. I might pass it back over. Phil, hello, how are you doing? Did see a few others earlier on in the chat that might not be with us as we speak. Might roll back through and scroll and shout out to them earlier. Stranger XX, how you doing? I've sent you an invite actually, Stephen Chess, if you want to join. Be good to see you. Along with a few others. As I say, we might get some other guests joining us as we progress. I don't know, I was intending to stay live for maybe about another 20 minutes. And then I know it's pretty late where Nick is probably gone past 1 a.m. by now. Or coming up for what is it? Coming up for 2 in the morning there now, Nick.
Yeah, it is. Yeah.
So, yeah.
But no worries. It's cool.
If Nick flakes out earlier, in the meantime, we'll carry on for about another 20 minutes. I mean, I know you want to change the subject, Anthony, but have you made any ground with Nick? I know you said you had a conversation in comments. Did that go any further?
I don't mind talking about this all night. I just don't want to hog the mic. No, Nick's passed a couple of comments over on some of the videos, but I've never had a dialogue with Nick at all. And he said you can pass over his Skype details later after the Hangouts, and that's cool.
And what about the other chap that you were chatting with, whose name I forget, that Flat Earth Asshole's been highlighting? What was his name?
Mick West.
Mick, that's what I meant. I said Nick, and I actually meant Mick.
Oh, sorry. Well, it kind of stopped because he got to a point where he was just basically saying, look, accept it or reject it. Take it whichever way you want. So obviously I took it the way I want, which is the way that it doesn't appear to be when I do the observations himself. Because I'm not seeing things that are bent beyond the curve. I'm not seeing things that he tells me that I should. When I look into the night sky, I'm not seeing stars slow down as they get to the horizon. I think it's complete and utter bollocks, but I can't prove it. So how do I prove something that I don't have access? I don't have the tools to be able to prove it with. So it kind of stopped. There were a few people giving him a bit of shit after I'd stopped speaking to him, and he did respond to the odd couple of messages even there, but I don't have the equipment to be able to test what he says to be true. I mean, I want to see these stars slowing down as they get to the horizon because, hey, guess what? If the sun sets from the bottom side up, it's got to be subject to standard refraction in exactly the same way that the stars are, if it exists at all. And these buildings are all subject to, everything's going to be subject to it, but I just don't see it in my own observation. So it kind of came to it, fettled out to a stall, and I've not had any direct contact with him since. I'm just trying to work out how I can test what he claims, which I don't even think I can see stars at the horizon. They seem to be bleached out. So I'm kind of at a dead end that I can't prove anything either way. So there's not been any progress.
Take a constellation everyone recognizes like Orion's Belt. When it's close to the horizon, those three stars are spaced a fair distance apart. As it moves overhead, they get closer together, and then as it heads to the horizon again, they pull apart again. So there is although it's not like race cars fast and slow, but there is a change in apparent speed when things get to the horizon or come up from the horizon. I don't think they're actually moving any faster or slower. It's just that they appear to.
See, I can't tell that from where I live. Anything that goes towards the horizon, like a star, it just gets lost in the background because we now got two major cities right close to them. Yeah, I just got light pollution everywhere, so I can't even observe that. I'd have to physically go somewhere rural to see the blackness of the night sky. And I mean, I could do the time-lapse photography on it and I could get it, but I'm gonna have to travel. So what's the name of that place in the Lake District?
Well, or Shropshire. That's probably the best place. I mean, my folks used to live there. I've said this a few times, but I wish I was still able to go there. They've moved since. But before I was a flat earther, I was in an area, or my parents were in an area of the least light pollution in Britain. And it was phenomenal. Some of the things that I'd seen just as a consequence of being in somewhere that didn't have any street lights. It was amazing. You know, I've said this before. I just like saying this, but the stars, as you let your eyes adjust, obviously most people will describe the nature of it getting more and more infinite. But I would say it's true the other way around. As your eyes adjust, it's almost like you could pluck them out of the air. They look like they're coming closer to you. It's very difficult to describe, but it is spectacular. But you only get that if there's minimal light pollution, which is a shame.
There is a website for stargazers that you put in your address or where you are, and it'll tell you the best place to go closest to your home for the best sky to do stargazing and stuff.
Yeah, that website is called Dark Skies. You can check that out, but I don't have anything that's relatively well. It is quite close, but it's just a journey and a half. And I'm thinking the best time of the year to do it would be winter. You know, when the sun's nowhere near us, because in summer for us at the moment, the sun's not that far away.
I'm just going to interrupt. We've been joined by Stephen Chess, and most of the conversations I have with Stephen, I'm left cold because it's phenomenal conversations, and some of the concepts that Stephen puts to me are astonishing. But the guy's too cool for school, and he's like almost indifferent, doesn't necessarily want to promote the information. So I'm going to try and drag out some of the things he's told me recently. I'm hoping you'll be keen to share them with you. Prepare to be astonished. How you doing, Stephen?
Oh, thanks, Nathan. How you doing? Doing well.
Oh, have you frozen? Hello?
Can you not hear me?
May have some technical difficulties. You're not on mute, so hopefully...
We can hear him, but his volume level appears to be 1 out of 10.
Let's have a look.
Shoot, guys.
Turned him up. Hopefully we can hear you now, Stephen. You can try.
Testing. Can you hear me? 1, 2, 3. No?
Perfect. Yes, we've got you. I've turned you up full and now we can hear you.
All right, cool. Thank you. I was just saying, thank you very much for the introduction, Nathan. Hey, what's up, Phuket? Sorry, I can't remember your name. My bad.
Nick, Stephen, Nick.
I should have remembered that. How you doing?
Good, man. Good. Yeah, I'm slowing down now. It's early in the morning now, but it's cool. Good to.
I should do some other introductions because I don't know who knows who. So also we've got Anthony Riley on the panel. I don't know if you've met Anthony before, Stephen.
No, I don't think so.
So Anthony, Stephen, Anthony, how you doing? Both of you.
Nice to meet you, my friend.
Yeah. I know I've heard you before. I've heard all of you, I'm sure.
I said to Jimbo when he joined, because I was mulling around as the Hangout was live, and suddenly I heard Jimbo come on. I was like, the dulcet tones of Jimbo. So soothing. Yeah, have you met Jimbo before?
No, but people in the chat were talking about his voice. I was just saying
everybody.
Yeah.
So yeah, again, Jimbo, Stephen, Jimbo, and Snack. I'm not sure if he's with us or not, but I'm pretty sure you have spoken to Snack before, have you not?
Yeah.
Cool. So enlighten us. Tell us a little bit about some of your weather observations, Stephen.
Most recently, I've just been sort of observing how the position of the moon in relation to the sun is affecting the temperature of the days, and how the progression of the days, you can sort of predict what kind of temperature days you're going to have based on the positions of the sun and the moon. So basically, if you know, like if you've been tracking it, the moon sort of loses 15 degrees on the sun each day, or the sun gains 15 degrees on the moon each day. So basically you have the moon cooling and the sun heating. So if you have the moon, like going before the sun, you're going to have cooler mornings followed by hotter afternoons because there's no moon on the other side of the sun. So yeah, just that. And also I've been observing relations between that and the correlations between the wind. So I'm thinking that there's correlations between the position of the sun and the moon and the winds that are occurring.
I mean, you've made these observations near water, and obviously you factored some of those things in as well. So you go ahead. Sorry.
Well, it's very specific to where you are, so it's going to be different for everyone all over the world. It depends on your location, of course. That's of course what's causing the seasons and differing conditions in different places in the world.
Right. And this is something that if you're observing it with your own two eyes, you're going to come to the conclusions that things are trackable based on the fact that we have mechanics in the sky that are pretty consistent. Whereas the equipment that meteorologists are using are pretty set in their standards of what they're looking at and how they're checking it. And of course, they're trained in a specific way on how to predict the future, essentially.
Yeah, it's like when you guys were talking about earlier, you have radar, blimps, balloons, balloon satellites, whatever you want. They're probably not using their eyes too much.
No, I mean, often they're on a top of a building, so they might have a wonderful flat Earth view for all I know, but they're going into some little shed and gathering up the rain samples, and that's how they're doing this stuff. And then it reminds me of when we went to the Space Center, and I was left horrified. Then I'm almost stumbling over my words just to repeat it. But when we went to the Space Center, they had one of the demonstrations there was for the weather broadcasters, and they showed you sort of green screen technology. And this is obviously not new to most people. You know, when the people are given the weather, then they haven't actually got the map behind them. They've just got a green screen presentation. But it was a slightly bizarre thing to have in the Space Center, you know, to show you how the weather was done. And the reason is obviously because they're getting the information from satellite data and various other things that are part of the heliocentric bullshit. And that's how they're, you know, they're not lying. They're just gathering up the data that they're presented with, and they've got no reason to distrust it. But it's very different to actually going out and observing cause and effect. You know, this is something that I said this the last time we chatted on air. That, you know, you're getting to the point where you can say to your friend, I know what the weather will be tomorrow, based on what you've observed with the sun and the moon's position, and knowing what you know about your location and the fact that you're near water and what the effects are when those two celestial bodies interact with one another.
Yeah, offer some people that you live with a bet about the weather, and when they know that you know what you're talking about, they're not going to do it. You know what I mean? But it's definitely, like I was saying about your location, it's definitely a very specific based on features around your location, you know, oceans, deserts, valleys like I'm in, you know.
Sure. I mean, is this something that's been wrapped up so much in deception that nobody's ever going to be looking and presenting the information in the mainstream? Or do you think that...
Well, there's certainly a science behind it, but there's features of it that are being overlooked.
Right, so omission as opposed to...
Like the moon being cold, having a cooling effect, you know?
I don't know if I agree with that.
It's funny because weather can be affected by the very things that we do and we create. When they ran Highway 95 through South Carolina years ago, it changed the weather. There were coastals that would blow in from the Atlantic 60 miles inland to Columbia. Now, Walterboro is halfway between. That's after the I-95 went up and started getting heavy use of traffic. The heat from all those cars, the asphalt, etc., causes a barrier, and these coastals that used to come in and rain up to 60 miles inland or west of the coast stop at 30 miles. And it's so evident because basically you can be in the parking lot of the Walmart in Walterboro at sunset, and when the coastals move in and that evening rain starts, it stops, and it's only raining on this side, on the east side of the parking lot or the Highway 95, and not on the west side. That wall of heat from the cars, the asphalt, whatever, literally stopped the air from flowing 30 more miles and providing rain for farms, fields, etc. That's just one road, one highway, and how it affected the weather for everything points west beyond it. It cut them off from their normal rain cycle. So they have a drought west of the 95 and no drought east of the 95.
Yeah, it's all huge. Everything you have to take into account, you know, everywhere you're living and everything around you.
It has an effect.
Yeah, it's interesting that here in Thailand they have the Songkran festival, which is the height of summer, and then it's a week-long thing, and traditionally or usually the last day is the day that the rainy season starts, and it tips down. It's been blazing hot for a few months, and then boom, the rains come, usually like clockwork. But you know, as you're saying, though, you know, we're changing the environment so much that these things don't happen so much. But it is related to the moon as well. All these festivals that they have here are based on a lunar calendar, and the seasons do, as a rule, correlate with, you know, the second full moon of the 8th month or whatever. So yeah, I mean, for a long time in many other cultures, they've been following the moon, and it's been predicting the seasons for them, the changes in the weather. So, Stephen, is it?
Yeah, Nick.
Yeah. So, I mean, yeah, this is obviously, you know, you're making some logical observations that, I mean, they always talk about the sun obviously doing all sorts of things and affecting us with electromagnetism, etc. But of course, they are both, the sun and the moon are clearly working in tandem.
Inverse opposites.
Yeah. I mean, and it's required, isn't it? I mean, it's just just that's how it has to be to actually have this physical realm. Either way we look at it, whether we can ever get to the root of it, it's some kind of intelligent design that makes it all happen. And yeah, the rains, the sun, etc. And to put it all down to some, you know, cosmic accident and the moon being a rock that ran into the Earth 4 point whatever million years ago or billion years. I mean, it's just insane to not just look at it for what it is and at least appreciate this natural.
Oh, I think we've lost Nick at the end of that sentence.
Oh,
we lost
yeah,
the end of that sentence,
sorry.
Nick, sorry. We lost
okay,
you
I
at
was just
natural.
saying, all right. Yeah, kudos, because yeah, we're observing the natural world. And again, you know, you can understand the kind of the awe and stuff that astronomers have that believe they're on a globe. I mean, yes, we've all got this burning desire to find out something about where we are, how it all works. And of course, you know, if you get some kind of familiarity with the stars, then and you've got this picture in your head about how it all works, then you know you can imagine, you can see how people are very they don't want to let go of that, and there's a certain affinity. They you know, it's this wonder that we all have. Every single one of us surely wants to know something or have some kind of idea about where we are. And if you can get some kind of familiarity with that, then of course, I think that's what you find in fact, I had a glober in a comment to me just before this chat saying you're never gonna, you know, a globe head's never gonna go flat and a flat earther's never gonna go to believing in a globe. So why don't you just give it up? But of course, you know, we know that they're not seeing it in the way that they could see it. There's this refusal to look at it in a way that's different to what they've been, what we've all been taught and what we're all familiar with.
Just respond to that point there. I've said a couple of times, if somebody was able to prove either curvature, axial rotation, or gravity, if you could prove any of those three things, I would lean more towards globe. But every time I get anyone trying to produce evidence that tries in their eyes to prove it, in my eyes doesn't. It may persuade me if I was to be. I mean, it's like the tidal locking of the moon. If you look at the moon and they tell us it's tidally locked to our Earth. If you think about orbital mechanics and you think about what they say in regards to how the moon got there and how it moves and how we move around the sun and how the sun moves around, to accept the possibility and the probability that the moon is tidally locked to Earth so that we never, ever, ever see the backside of the moon, it's preposterous. The chances of it actually being true are so unbelievably small that it's just, you can't accept that it's the reality.
Well, I'm going to round out soon, but I'm going to ask one final question to every panel member, and hopefully we'll still have Nick so we can say goodbye to him before we round out, and I'll thank you all as well. But if I can just ask you all this final question. So earlier, Jimbo said that, or alluded to, the moon not being a physical object. And I'll be the first to answer this and say, from my observations, it would appear to be a physical object. So maybe if you can hear us, Jimbo, if you can start by, you know, maybe qualifying what you've already said, that'd be brilliant. And then maybe move on to Nick and so on.
Well, you know, we see something, we can see shadows, we can see all kinds of things. It doesn't mean they have mass or substance. The best reference I can get is to a magic trick. It's basically called the Chinese magic mirror. And what it is basically a specially designed mirror, nothing fancy, but if you look at it, you'll see your reflection in it. But if you shine a light onto it and have that reflection shine onto the wall, you will see anything that's been engraved or printed on the subsurface of the mirror. i.e., if you do a YouTube and look up Chinese magic mirror, you can get a better idea of what I mean. The reflection can look like it has craters and valleys, and it can be a reflection of anything. The best way to describe it is to show it. And if you want, if you got a minute to put on YouTube and just show 2 minutes of a Chinese magic mirror, the phenomena, the appearance of that light on the wall from the mirror's reflection looks like an object. It looks like something that's very real, very dimensional, yet it's just an illusion. It's just a reflection. I get back to the part that if the Earth is flat and 70% or more water, it's a mirror surface. All water is a mirror surface. But if you have just 1 minute that to YouTube it and maybe present just one demonstration of a magic mirror, it gives you a lot better idea of what I'm trying to express. And like I say,
I'll have a look on YouTube. If I don't find it before the end of this broadcast, I will stick a link in the description box. But while I'm looking for that, Nick, if I can get the same answer from you in terms of what you think the moon is, that'd be wonderful.
It's just part of the big clock in the sky, as far as I'm concerned. One of the immediate conclusions I reached, well, not immediate, but looking into the whole flat Earth thing, you get to that point where you realize that maybe we're just not supposed to know how it all works. And this, again, leads us to the understanding that it's intelligent design. And we can all debate it until the cows come home. And of course, the biggest psyop in history has been, this idea that we've been able to go there. But no, as far as I'm concerned, and the way I see it used in especially Asian cultures, is it's really to tell the time. Maybe not just for us, but for every creature and plant on the plane. That's what it does. How it works, we can probably never ever get the answer, but the reason it's there is to tell the time.
And I'll pitch in. I think that the moon, whatever the moon is, for me is kind of evidence that directly contradicts physics. And it's absolute evidence of creation in my eyes, because it doesn't conform to any of the known physics. You look at things like, oh, well, it's 240,000 miles and we measured it from this. And then you see the harvest moon in autumn and you realize that there is no explanation on the heliocentric model for why the moon appears to be 8 to 10 times bigger than what it normally is. And that's my interpretation of God just saying to us all, or the creator or the grand designer or whatever you believe is creationist. Whatever that figure is, he's looking down on the moon and saying, "Hey guys, I'm fucking with your head. Watch, explain this science," and he'll move the moon in and out just to fuck with us. So for me, it's evidence of creation. In terms of its construct, I have no idea. I liked the idea. I heard some recently where NASA apparently, quote, nuked the moon and it rang like a bell for, was it 3 days or 3 hours or something like that? I have no idea. I don't know is the honest answer, but I lean towards that it's evidence of creation and direct evidence against science. So I don't know is the short answer.
That's fairly reasonable. What about you, Stephen? What say you?
Well, I think that the moon is a conduit, just like the moon, or just like the sun. The sun being a positive energy conduit and the moon being a negative energy conduit from the north and to the north. Whatever it is, it's whether it's a rock or a lens. That seems like an interesting theory. Sorry, the monkey picture, I can't remember names right now.
Jimbo.
Jimbo, right on, man. Yeah, that was really good. I enjoyed that part. Yeah.
Cool. I would ask Snack to the future, but it seems that he's dropped off. He may have been having technical difficulties. So I think we've pretty much rounded out. And with that, I'll thank, first and foremost, Nick from Phuket Word. Well, I say first and foremost, just first. So thank you very much for being here, Nick. It's been an absolute pleasure as always. That was a muted yes. It's been a pleasure to be here, Nathan. From Nick.
Yeah, no, just thanks to you and all the other guys for some wonderful discourse. It's great just to kind of hear other ideas and observations and acquire more knowledge. That's what it's all about. And great, thanks a lot. Yeah, cheers.
And again to Anthony Riley, thank you very much for being here. Second time in just a few days. So thank you very much for being here, Anthony.
My pleasure, Nick. I've put my my Skype contact in the side chat. If you just hook up with me sometime, I want to arrange a three-way conversation with you and my friend about what the Southern Stars and stuff. But thanks, Nathan. It's been a pleasure. I'll speak with you soon.
And indeed, James, thank you very much for being here, Jimbo. It's been good to chat to you for the first time.
Been good, Nathan. You enjoy it. It's been a good show. Many more to come.
Thank you very much. And last but not least, Stephen Chess, thank you for partaking and giving us your wonderful information. It was fantastic as always.
Thank you. Cool for dropping in.
Super. And to all of you who have joined us live and in the chat, it's been a pleasure having you. Thank you very much for joining us. Be sure to like, share, subscribe, and indeed comment below. I've been Nathan Oakley. I will see you all in the next video.